Hello, everybody can do 13 plus 24 equals to 37, right? But I bet everyone was working on the tens digits and the ones digits separately. Work out the answer before you combine them back into 37. So in vectors, we have something similar, and it's called resolving vectors. For example, we have an object moving at a velocity v, which is at an angle of theta above the horizontal. Because gravity acts only downwards, it's actually easier to work with the horizontal and vertical components of the velocity separately. So we want to split this velocity into its horizontal and vertical components. So how do we do that? First step, imagine a rectangle first. Alright, so the rectangle will have horizontal and vertical sides. Now, try to wrap this rectangle around the vector that you are trying to resolve. So it's going to look like this, right? So notice the vector that you are trying to resolve is the diagonal of the rectangle. This means this side of the rectangle is the horizontal component and is going to be v cosine theta. How do we know that? Well, look at this right-angled triangle. So this is the hypotenuse and this is the adjacent side looking from theta, yeah? So that's why this is v cosine theta. What about the vertical component? This will be the vertical component and it's v sine theta. So how do I know that? Look at this right-angled triangle, yeah? So this side is the opposite side. That's why it's v sine theta. That's why this one is v sine theta. Okay, now let's say there's a mass that's on a slope, inclined at an angle of theta above the horizontal. Well, there's the weight acting on the mass, right? Now we are going to resolve the weight into two components. Then you say, wait, isn't the weight already vertical? Why do we want to resolve it? Well, it's because the motion of this mass is likely going to be along the slope. Because of that, it's actually to work with the components of the weight horizontal and perpendicular to the slope. Get it? So instead of a vertical weight, we want to split it into two components. The component that's along the slope and the component that's perpendicular to the slope. So let's bring in the rectangle again. Now last time, because we want to resolve vertically and horizontally, the rectangle has sides horizontal and vertical. But this time round, we need to imagine a rectangle that has sides that's parallel and perpendicular to the slope. Get it? So the rectangle will be oriented this way. It's going to be a slanted rectangle. So now can you wrap this rectangle around the weight? So this is the one, right? So notice again, the weight, which is the vector that we want to resolve, is the diagonal of the rectangle. Which means this is the component of weight perpendicular to the slope, and the other side of the rectangle, this side here, is the component of weight along the slope. Now, what is the magnitude of these two components? That means we need to figure out what is this angle. Does it look like theta to you? These two angles, do they look like the same angle to you? I hope they do, because they are the same angle. So how do we see that? I think the easiest way is this. So this theta here is formed by the slope and the horizontal, right? Whereas this angle here is formed by the vertical line and the line that's perpendicular to the slope. But then you realize if you rotate the slope line 90 degrees, you get this line. If you rotate the horizontal line here, you get the vertical line here. So do you see that it's very obvious that this angle that's formed by these two lines is the same as the angle here, which is formed by these two lines. Well, anyway, after you have done enough problems, you know that this angle is the same as this angle. Okay, now that we know this is theta, that means this component is w cosine theta. How do I know that? Look at this right-angled triangle, yeah? So this is the adjacent side, that's why it's cosine theta. Which means the other side must be w sine theta, right? How do we know that? Look at this right-angled triangle. So the length of this line is the same as the length of this line. This is the opposite side of the right-angled triangle. So it's W sine theta. Now resolving vectors is a very basic skill in A-level physics. So make sure you can wrap the rectangle properly and then work out the two sides. Alright, that's all. Ta-ta!